People have been arguing for centuries that 0.9 recurring can't equal 1. This might be because we can produce a pretty good argument against any proof that 0.9 recurring equals 1. And we will examine one of those arguments now. Next, we have the often overlooked issue about notation, representation, and actual numbers themselves. If we are writing numbers down using the same system of notation based on power of 10 place values, then surely for two numbers to be the same, they should contain exactly the same digits in exactly the same places. But we're told to not be concerned that 0.9 recurring and 1 contain completely different digits in every significant decimal place, because these symbols are just representations of exactly the same number. They are not the number itself. So what does this mean? Well, we are told we should not expect a number system to be unique. For example, a half and 2/4 are two different representations for the same rational number. But if 2/4 isn't the number and a half isn't the number, then what is the number? If we think about what a number is on a computer, then surely the binary bits that represent the number are the number itself. An irrational might be stored as two integers, one for the numerator and one for the denominator. And yes, we can convert one rational representation to a different rational representation, but if these are not numbers themselves, then what are numbers themselves? And since we can't actually store infinitely many digits on a computer, is it really valid to presume that infinitely many digits can somehow exist? Perhaps we should find out if we could actually locate these mysterious numbers wherever they are. Some people confidently think that they've resolved the issue by saying that numbers are just concepts. But what exactly are concepts? Say we imagine two cats on the moon, then surely the number 2 is just a data item in the brain that forms part of the description of what we've just imagined. And so if numbers are concepts, then surely they are just data items in brains. And if numbers on computers are just representations of numbers and not the numbers themselves, then the same can be said for brain data items. And so we still don't know what an actual number is. A mathematician might use the axiomatic system known as ZFC to claim that the number represented by a half and its equivalent representations are the ratio of the cardinalities of the sets that correspond to the natural numbers 1 and 2. So now we need to understand what a ratio is, what a set is, as well as what it means to construct things from sets, together with everything that accompanies these concepts. And with all these new concepts, are they representations of things, or are they the things themselves? To say that they are all just concepts doesn't really shed any light on the matter. Let's start by trying to understand what a ratio is using a very simple real-world example. For any given classroom, should it always be possible to state the ratio of pens to pencils in the classroom? Already we hit multiple issues. If the first quantity is 0, then we haven't got a proper ratio, because 0 to a non-zero value is conceptually the same as 0 to any non-zero value. And if 0 is the second number, then the ratio is apparently not well defined because of the implied divide by 0 problem. A simple solution would be to define that any ratio containing a 0 refers to exact quantities, whereas other ratios refer to relative sizes. But mathematicians won't do this because they want two number ratios to be conceptually equivalent to fractions. And what they want, they get. This raises an important fundamental question. Should reality dictate mathematics, or do we discover abstract mathematics not connected to reality and then retrofit it to the real world? If mathematics was akin to a programming language for modelling physical activities, then we would construct it to correctly describe physical scenarios. And if we encounter a divide by zero, then it would mean we've made a mistake in our modelling. But instead, we try to retrofit abstract mathematical concepts, which unsurprisingly result in problems. And we've got all these problems before we've even started to try to get a clear understanding of sets. But the mathematicians will dismiss all these arguments, and they might even call us crackpots for even suggesting that there's a problem. So in order to try to understand what a number itself actually is, we have gone down a rabbit hole, where apparently everything is built up from sets. So now we need to know exactly what a set is, rather than what represents a set. And how did they describe the number represented by a half before set theory was invented? We might suspect that numbers were meant to represent physical quantities in those days, and so half of a standard cake and 2/4 of a standard cake could be said to be equal based on the quantity of cake they contain. But we'll be told that people were mistaken about lots of things in the past, and now we need to go away and study set theory until we see the light. Finally, thank you for taking the time to watch, and I hope you enjoy my other videos.